I am Anil Kumar. Welcome to my series on calculus. Let me first congratulate all my students and especially Gurmeen, who has been judged as one of the best in her class. I am going to discuss with you a test paper of last year, and I have picked up many questions from Gurmeen's test paper, and I hope their solution will help you all. Right? So that's the test paper from which I have taken 5 questions. The other questions we have picked from previous year's test papers. The questions which we are going to discuss are something like this. You can always pause the video, copy these questions, answer them, and then look into my suggestions. So, in no order, I'm just placing the questions which we are going to discuss. This is the second question, which is on limit. So basically, all the questions will be based on limits, continuity, and derivatives. So in no particular order, these are the questions which we are going to answer in this particular video. I hope that will give you a jump start in your school. Have a good look at them. So that's the variety which we should understand for understanding the very first and second unit on calculus. The first unit being on limits and the second on basic derivations. We have all kinds of questions here, and I hope this series will be of use to all of you. Anil Kumar sharing with you a test question based on limits and continuity. The question here is, given the function f of x equals to 3 minus 4x minus x squared, using first principles, determine the point at which the slope of the tangent line is 2. Part B is, determine equation of the tangent line in standard form at the point found above. So we have to find a point at which the slope is 2 using the first principle. We are given f of x as 3 minus 4x minus x squared. Now, first principle says that the derivative of this particular function can be found by using the definition of limits, right? Limit when h approaches 0 for f of x plus h minus f of x over h, right? So we have taken 2 points which are very close to one another, and then we can find the slope of the tangent as a secant slope approaches the slope of the tangent. Now here, let us substitute the value in the equation. So when we say x plus h, we get what? Limit h approaches 0, we get 3 minus 4 times x plus h minus x plus h whole square. So that is f of x plus h minus the function, which is 3 minus 4x minus x squared divided by h, right? Now let's expand this. We get limit h approaches 0. So we have 3 minus 4x minus 4h. Open this also, minus x square minus 2xh minus h square. Here we have in brackets 3 minus 4x minus x square, right? Divided by h. So 3 terms, these 3 minus 4x and x squared. These 3 terms will cancel. We're left with terms with h now. So it could be written as limit h approaches 0. So in these terms we can take h common. So when I take h common, I get minus 4 minus 2x and minus h in the numerator. Denominator is h. They cancel. So now we get our limit, right? So we can say that the limit is equal to, let me rewrite this as limit h approaches 0, and here we have minus 4 minus 2x minus h, which is equal to, substituting 0 here, we get minus 4 minus 2x, right? So that becomes the general expression for our derivative. Now let's look into the condition. Using first principle, determine the point at which the slope of the tangent is 2. So slope is 2. That means we'll equate this to 2 and find the value of x. So we get minus 2x. So bringing it here, we get 2 plus 4 equals to minus 2x, which is 6 equals to minus 2x. 6 divided by minus 2 is x, which is definitely minus 3. So the value of x is minus 3. Now we will substitute minus 3 in the function and value of y will be found, correct? So we have 3 minus 4 times minus 3 minus minus 3 whole square. So that is 3 minus minus becomes plus 12, and that is minus 9, right? So what we get here is 12 minus 9 is 3, and 3 plus 3 is 6. So the point which we are interested in is basically minus 3, 6, right? So that is the point. So we got the first part, which is the point P is minus 3, 6, minus 3, 6, right? Now the second part is determine equation of the tangent line in standard form at the point found above. So in standard form, we have to get the equation. We know slope basically is what? Let's find the slope is 2 is given to us. Slope is 2, right? So slope is 2 at this particular point when you substitute minus 6 here. So we get 6 times to minus 3 here. So minus 3 is plus 6. We get slope of 2, correct? So the equation in standard form now can be written as y minus y2, which is 6, equals to slope m times x minus x2, which is 3, correct? So from here we know y minus 6 is equals to 2x plus 6, and that can be written as, I'm just squeezing it in, we have here 2x taking y on this side minus y, minus 6 plus 8 when it adds up becomes plus 12 equals to 0, right? So that becomes the equation. So we get the equation as 2x minus y plus 12 equals to 0. Is that clear? So that is how we are going to solve this particular question. Now let's take the next question of this test paper, which is find the constant a and b such that the function f of x is continuous for this closed interval 3 to 0. F of x is a piecewise function, minus 3x plus 4 when x is between minus 3 and minus 2, both included, and it is ax cubed plus b when x is between minus 2 and 0, and it is equals to 0. At x equals to 0, it is 4. We need to find a and b, two unknowns, so we should get two equations. So for the function to be continuous, what should be true? Well, their values at minus 2 should match, right? So what we will do here is at x equals to minus 2, what we have here is minus 3 times minus 2 plus 4 should be equal to, substituting minus 2 here, a times minus 2 cube plus b. So that gives us plus 6 plus 4 equals to minus 8a plus b, or 10 equals to minus 8a plus b, correct? So we get one condition. The second one we'll get from the other two. So at 0, at x equals to 0, we should match the values. So on the left side, we get a times 0 plus b should be equal to 4, right? So that gives you directly the value of b as 4. Now, let's say this is equation 2, this is equation 1. Now we will substitute 2 in 1. So we get 10 equals to minus 8a plus 4. And from here, we can find what a is, correct? So taking 4 on this side, we get 10 minus 4 equals to minus 8a. Let's solve it on the left side. We get 6 equals to minus 8a, or minus 6 over 8 is equals to a, which is clearly 3 over 4 negative, right? So we get the value of a. So the answer for us is A is equals to minus 3 over 4 and B is equal to 4. So if A equals to minus 3 over 4 and B equals to 4, then the function is continuous. So I hope that that's absolutely clear.